Hi, everyone, and welcome to the MLOPs Live webinar series, our first session of 2021. It's great to have you back with us today. I hope you're all rested from the holidays. For those who are joining us for the first time, my name is Sahar, and I'm the VP of Marketing at Iguazio. And MLOPs Live is our webinar series dedicated to operationalizing machine learning and bringing data science into real business applications. Before we start, I'd like to invite you to join our MLOps Live community on Slack and connect with over 250 data science practitioners. This way, we can keep the conversation going after the session. We'll drop the link in the chat box now. And today, we're going to be talking about simplifying deployment of machine learning in hybrid environments. We see from our customers and the industry at large that the need for hybrid solutions to manage data and data science applications is growing all the time. This can be attributed to increasing regulation, especially in industries like financial services, healthcare, and so on, and data privacy considerations, which are constantly becoming more and more of a concern for companies across verticals. The problem is that the challenges involved in operationalizing machine learning only increase with hybrid deployment and when scaling data science across the organization in general. I imagine that's why many of you have joined us here today. But good solutions exist to overcome these challenges, and this is exactly what we'll deep dive into now. To walk us through this topic, we're delighted to have Rob Zarnecki, Principal Product Manager of AWS Outposts, here with us today. Together with Iguazio co-founder and CTO Yaron Haviv, they will take us through the challenges of running machine learning in hybrid environments, discuss main use cases and applications, and share solutions for achieving the same simple experience and leveraging the same tools across both cloud and edge. We'll finish off with a live demo showing how to run a distributed cloud and edge application with AWS and Iguazio. In between, we'll be running a short 2-question poll to hear about your experience with hybrid deployments, so please do fill that in. These polls help us make these sessions as valuable as possible for you. And as always, we'll share the results at the end. Feel free to ask questions in the Q&A panel at the bottom of your screen, and we'll make sure to address them as we go along or at the end. We've now put everyone on mute, and we're recording the session so that we can send it to you afterwards. So without further ado, I'll hand it over to Yaron to kick things off.
Thanks, Sahar, and thanks everyone for joining us. So can you move to the next slide? So when we're talking about MLOps, we're essentially trying to help operationalize machine learning. And part of the challenge in machine learning is also the federation, the fact that you're not necessarily using everything in one place. You may have some on-premises tools, you have maybe something in Amazon, maybe in other clouds, and that adds some challenges to the existing challenges. But to begin with, the existing challenges in operational machine learning start with the fact that we have siloed work of teams of DevOps and data engineers and data scientists, and they work in different environments. And add to that the fact that when you're in the cloud and on premises, you're using different tools. That even makes things more complicated. You have the challenge of deploying things to production. So while in the cloud, it may be slightly simpler, you're using managed services. On premises, it's harder because it's usually revolves around traditional IT. Then there is a challenge of accessing features and data. Data doesn't necessarily sit in one place. It's not necessarily in your data lake in the cloud or on premises. It may be in both. Data may be dynamic. And we need access to all the data. And sometimes just being in one place limits us. Maybe not all the data is in the cloud. Some of it is on premises. Some of it is coming from streams, from sensors. And finally, we need to address the aspects of model accuracy. And we do that by constantly tracking and monitoring the models, making sure the training data and the serving data are essentially identical. And that also possesses some challenges where you're in a distributed environment. Next, Star. And one of the most critical challenge in operational machine learning is handling and moving data around, as we discussed. Take this diagram. which shows a typical machine learning pipeline in production, which means collecting data from a variety of sources. Some of those are ETLs using from traditional databases or from data lakes, but some of those are real streams from actual sensor data or web logs. Some of it is integration with APIs. And then we go and puts it into an offline store and an online store later on for serving, and we need to do the training and serve the models and all of that. So most of the challenges here are not just doing the training. Today we have more and more tools for AutoML, which make the life of training simpler. The key challenge is how do we mobilize, analyze, process the data in such an environment. Next. So if we look into what does it take today to build machine learning, we essentially have three different environments. One is the research, the second one is sort of the production deployment, and the third is how do we monitor all the activities. That's sort of the monitoring and governance layer. When we're in research, we take data from a data lake, we do batch transformations, we do training, and then we need to move to deployment in production. Now we use other technologies. We actually latch on real operational databases and real streams, and we process that data and serve that. And finally, we need to also analyze and govern. So in those cases, what if, for example, data lake is in Amazon in S3, but the deployment is happening on sort of some edge location or on a ship or on a local data center, or the other way around. Maybe the data, due to regulatory compliant issues, have to be in a bank or in another facility, and we have to do the training there. And then the deployment of the endpoint in some application that sits in the cloud. So this creates challenges, again, using different tools, different practices on those different environments. Next. And again, as I mentioned, are some of those challenges, like lots of manual processes between the data science and the data engineering, and MLOps, refactoring of code. We talked about the hybrid environments where some of those things need to sit in different locations, and so on. Next. So really what we want to achieve is something which is more uniform. So uniform more in the on one end on the APIs that we use, on the infrastructure that we use, but also in the software methodologies and APIs that we use. So the first thing that we need to do is handle the data in sort of a uniform way. And this is where we're talking about the concept of a federated feature store. I think that by now you understand what a feature store is essentially the feature engineering pipeline alongside the cataloging and management of all your features. But sometimes some of the features exist on premises, some features happen to be in the cloud, and maybe even the batch ones are here and the real-time are in the other place. So we need a way to federate the different definition and the transformation logic across those two. And also we need the serving part and model monitoring part, and sometimes even the operational data, they're also located in sort of the on-premises or the edge location. On the other end, aspects of training on lots of data or analysis, sort of post-mortem analysis, or the data lakes may sit on a different location. So this is an example of some of those deployments and configurations. And with that, we're going to talk to Amazon, and Rob here is going to explain a little more about what they've done in Amazon with Outpost, which is essentially sort of a mini Amazon, but again, sort of missing some services that Rob is going to talk about. And then I'm going to show how we can essentially build a fully uniform federated architecture across both Amazon Cloud and SageMaker, and essentially develop something in, sorry, not SageMaker, Outpost, but we can develop something in SageMaker and deploy it on premises on Outpost, and we'll show a live demo of that. So without further ado, thanks, Rob, and here's the mic moving to you.
Thanks, Sahar. You're on. Thanks, everyone, for joining today. My name is Rob Zarnecki. I've been here with Amazon for just about 6.5 years. And today I look after product management for AWS Outposts. And I just wanted to key in on a point that Yaron made when he mentioned that moving data is hard. And one of the things that we've learned over the last 16 years that we've been here building AWS is that you can't fight physics. So while we might not be able to overcome the speed of light and move your data faster or make it easier, we can bring AWS services to you. And that's what we're really excited about with Outposts. So for those of you who aren't familiar, AWS Outpost is a fully managed service that offers the same AWS infrastructure, AWS services, APIs, and tools, and allows you to bring it to virtually any data center, co-location space, or on-premises facility of your choice for a truly consistent hybrid experience. Now, worth adding that you still do need a physical place to put this rack, some power, and some network, but beyond that, it's really able to be placed anywhere that works for you. So as you're looking at our rack here on the screen, it's a great time to tell you a little bit more about them. The Outposts are delivered to you in a standard 42U rack. It's 80 inches tall, 24 inches wide, and 48 inches deep. And these are designed for high availability. And that means we build them with redundant networking switches and power connections, and recommend that customers provide independent sources of power and 2 network paths with to provide that resiliency in the connection. And when customers provision their Outpost, they can select how much compute capacity is loaded into that Outpost rack to make sure that they've provisioned with sufficient resiliency to keep their workloads uninterrupted through any temporary hardware issues. Of course, AWS manages the service, so we'll come out and take care of any issues within the rack or hardware replacements within just a couple of days. And we can even help you determine where you need to put your Outpost, and whether that's in your own data center, in an existing co-location facility next to some equipment that you already have, or even if you need help finding a new co-location facility. And then we'll just take the pre-assembled rack to your location and quite literally roll it into position and plug in the power and network. The installation's done by an AWS team. As long as the site is ready, it goes smoothly. Now, the real magic of Outpost is that it uses our same Nitro system, which is the AWS design infrastructure that we use in all of our regions today. And with Outposts, we found that customers can really increase their productivity and innovation because they can take that same development, deployment, and operational efficiency that they've built in the cloud, and they can extend it to workloads that need to run in a place where there's not an AWS facility today. It really allows you to bring our services locally and then connect back to the region as you need them to have a truly consistent development experience. And that's what we found customers have really loved over the past 13 or so months that Outposts have been generally available, is that they don't have to change their tooling. They can use the same deployment tools and monitoring tools, and they can get, whether it's a low latency response time or the ability to process data locally before sending it back to the cloud, and accelerate their workloads. Now today you can land an Outpost in 51 countries. We're working on more to come in 2021, and you can connect them back to any of our regions globally, with the exception of China. Now, the benefits of our hybrid model, it's important to realize, are not just limited to developers and IT. They extend also to procurement and finance and lines of business teams across our customers. And again, that consistent hybrid experience is so important, especially for growing businesses that need to easily scale process and have become used to that same pace of innovation that they see in the cloud. So that same reliable, secure, high-performance infrastructure that provides the same operational consistency you see in AWS regions today has been incredibly important to customers. And that keeping pace with that cloud-like innovation is a huge differentiator over existing infrastructure that customers use today. And what we see with Outposts is it's really an evolution where we find the customers have a continuum of applications, and some are easier and some are harder to move to the cloud. So for example, application modernization in the past needed to be carefully planned, but now with an Outpost that can just be delivered and added to the local network of existing infrastructure, the work required to architect that move carefully and make sure monolithic applications could weather the round trip time to an AWS region and back is no longer an issue. It's really accelerated those modernization efforts. Latency, of course, is it gets right back to that speed of light issue that customers who need responses quickly to locate their compute and their storage close to other systems, branch offices, end users, or the like. They can solve that problem by bringing Outposts close to where their end workloads are running. And they're also terrific for data residency use cases with this ever increasing set of regulations for things such as financial data and healthcare and medical records. The Outpost can house that data in the country, state, or municipal area that it needs to be kept in. And it also allows customers to do local data processing, which is a slightly different variant on the latency use case, and quickly get that data processed, for example, to send an autonomous vehicle back out on a road, or send a plane back for its next flight, while being confident that they've quickly been able to digest the data that was pulled off of that aircraft and know that it's safe to send back out into the skies. Now, part of delivering this Outpost experience, it includes looking across our swath of services that we offer on AWS and bringing the right core set of services to Outposts. So when we launched back in 2019, we just started with the absolute core services, EC2, EBS, our container services, and EMR for some local analytics. Through 2020, we more than doubled that set of services, bringing things like local RDS for a managed database, our application load balancer, Elasticache, and S3 for local object storage to Outposts. And just like compute on Outposts, S3 makes it easy to store and retrieve your data on Outposts using the same S3 APIs and features for things like security, access control, tagging, and reporting that you're able to use with S3 in our AWS regions today. S3 has really been a terrific tool for customers with those data residency requirements. But we also continue to invest in features for all of these services, things like networking enhancements, monitoring improvements, compliance. We realize that we'll never have all 200 services that we do have in an AWS region, but that's okay. We don't think that we need them. And part of that reason for that is that we believe many workloads can be architected to use services in the region and also some services on the Outpost. And as we continue to work with customers, we've learned that customers want consistency, not just between their Outpost and the AWS region, but also between their Outpost and other existing hardware they may be running. And that's why back in September, we launched the Outpost Service Ready program. So as a customer, the Service Ready program gives you access to validated solution offerings that can help accelerate and simplify your Outpost performance to assist with things like monitoring application performance or delivering meaningful insights faster. And each of these partners have undergone a well-architected review with AWS technical experts. So we've confirmed that they're well-built solutions. They've actually been tested on an Outpost in one of our labs, and they've published deployment documentation that they've worked with AWS to review and reference architectures. So this makes it really easy for you to know that you'll be well supported in finding and deploying an integrated solution on Outposts for whatever you need. We've had a really great response from customers telling us which partners are important to them, which partners they might already be using, and which partners allow them to extend functions beyond the services that we provide. So we launched with 34 partners in September. We added 24 more at reInvent for a total of 56 partners, and we're continuing to add more partners to the program every month. And please feel free to share any preferences that you have for other solutions that you'd like to see as part of the Outpost program. But importantly, we're not planning to slow our pace as we move into 2021. We'll continue turning the crank hard and fast and deliver new services and features based on customer demand. We're especially excited about our new single server form factor, which will allow customers to deploy a 1U option with an AWS Graviton 2 processor or a 2U option with an Intel processor. Now, these are rack mountable Outposts, which means that you can easily install them in your existing racks, either with your own on-site personnel or an AWS third-party vendor. And it's important to remember that while the full rack outposts can be combined to up to a 96 rack footprint, these smaller servers can be joined together up to 6 at a time. So it really provides a nice way for customers to start with a single server, scale up to a group of servers, then if they need to move to a rack, expand to multi-racks, and ultimately build themselves a footprint that could frankly begin to approach the size of an AWS region or local zone in their own facility as they need it. Now again, these small outposts are still outposts, so they're fully managed by AWS and will seamlessly extend services like EC2 and EKS to allow you to deploy applications to even more sites that could not accommodate a full 42U rack. Of course, as we continue to build our roadmap and deliver services and features, more than 90% of what we build is based on our customer demand. And we'd love to hear from you on what you'd like to see next. So feel free to reach out to me on Twitter at Rob Zarnecki or through any contact info provided here. And really interested to see what your teams do with Outposts. Back to you, Sahar and Yaron.
Thank you, Rob.
So Rob was covering Outpost nicely, and as we discussed, some of the challenges is that you have some services that don't exist in Outpost, but on the other end, most of the infrastructure related ones are there, including things like Amazon EKS and Kubernetes and S3. And essentially what we've been doing together with Amazon, and I'll show some more details in a minute, including some nice benchmarks that we ran, is trying to build one solution for machine learning, for operationalized machine learning, where you can essentially go and develop in the cloud and deploy on Outpost, or the other way around if you'd like, on a single essentially stack. And most of it, by the way, is open source, leveraging MLRun, which is soon going to have a new version with significant new functionality. Some of it I'll show now. So if you look at the stack, then you have the Kubernetes using EKS on top of Amazon Outpost or AWS with the different storage and VM APIs. On top of it, you need some extra services for data, because as Rob mentioned, you don't have like streaming, NoSQL, and some other essential services for building real-time pipelines. So this is where Iguazio brings the real-time data layer. And then we want to essentially bring sort of serverless technology to fit into this sort of building machine learning pipelines. And this is really where things like MLRun and Nucleo fit in. And you need some orchestration to manage the federated environment or the deployment of the models from cloud to edge, or managing the pipelines, or managing the CI/CD for the process, etc. So we have one stack where on one end you could push things into it, like build models in SageMaker and then try to deploy them, run all the different services that you need on the edge. Sort of some of them are missing. You can run them on this stack on top of Kubernetes with alternatives to, you have something like Athena, which is essentially a managed Presto, or you have things like Nucleo, which is essentially a real-time serverless engine. Or for building pipelines, you can run something like Kubeflow on top of it, and so on. On the monitoring aspect, you do need different levels of monitoring. So on one end, things like experiment monitoring, pipeline monitoring, infrastructure monitoring, etc. So this sort of stack also addresses that. So when we look into the actual Outpost stack, how we build something in an edge location or on-premises location, we take Amazon Outpost with the hardware and sort of the lower level components, VMs, storage, etc. On top of it, you do need a set of data services to run microservices and machine learning. You need time series databases, you need streaming and message queues, you need NoSQL tables, and a distributed file system to be able to run all those things above. This all comes from Iguazio data processing and storage engines. On top of it, you put EKS, which is essentially a distributed Kubernetes. And on top of that Kubernetes, you essentially run all those different services that you need for analytics, for machine learning, and for MLOps and DevOps. So this allows you to build sort of a full stack. And on top of that layer, you have higher level functionality of a feature store, again, that could be federated and connected to the cloud, an orchestration layer for pipelines, for CI, for CD, for real time, and all sort of the full lifecycle management. Now, as you build this sort of appliance on premises, on one end, you can connect to data and local sources or local interfaces like dashboards, real-time sensors coming from machines, local databases, local storage. You can feed it into that machine. You can run different computation tasks, inferencing, analytics, and so on, respond immediately. And then you could also integrate with the cloud, because maybe the cloud is where you're going to run the training, or maybe the cloud is where the majority of the data is going to exist, or maybe the development happens in the cloud and you just want to push containers from the cloud into the edge or the central dashboard or control plane. So this is how we can build such a solution. And again, one of the core components here in the solution, on one end is having the data, on the other hand is having sort of higher level management for serverless and for services and serverless processing. So just taking what we've done together with Amazon, as Rob mentioned, they've done certification and benchmark with each one of the partners that's part of that program. So this is sort of some benchmark results that we've achieved on Outpost, and we're pretty proud of them. Iguazu provides some Amazon-like functionality, just running on sort of more of a real-time layer. So we have DynamoDB-like APIs, pretty similar to the original Amazon DynamoDB APIs, almost identical, and the Kinesis APIs. And also there's Nucleo, which is a real-time serverless engine. So running a single virtual machine, not a full cluster, a single virtual machine, and going against it with sort of queries of NoSQL, we managed to achieve 50,000 transactions per second using a single virtual machine. I don't know if you know how to translate it to how much you will pay on Amazon Cloud for those 50 TPS, but it's a huge amount of money. And also the latency for access to those NoSQL queries is less than half a millisecond response time for more than 90% of the IOs. That again, it's faster than most in-memory databases, if you're familiar with the numbers. And same for streaming data, we managed to push like 1.1 million records per second. Again, single virtual machine, not a big cluster. And using Nucleo for running machine learning, real-time machine learning job, we managed to push like 16,000 requests per second on a single function, single container running on a single VM of Outpost. So again, you're not sort of giving anything away. You get essentially the functionality that you need with extreme performance and extreme cost effectiveness. And one example of a case study that we have with a federated solution is managing patient analysis and things like that in a hospital. So within a hospital, you have medical records, you have real-time data coming from patient sensors and things like that. You can't just push it all the way to the cloud. You know, also system have to be extremely reliable. You don't want to wait for, maybe you have intermittent connections. And again, there's a lot of legal reasons why people don't like taking data away from the hospital. So in this case, you see that all the sensors from the patients, from existing medical records, all that feeds into one place. There's real-time analysis that happens on all those sensors. And based on that, it can throw alerts, can bring dashboards. This is a real dashboard for like patient deterioration. And this works also in an integrated way with the cloud. So this is an example of how to build a federated application and still not giving away any complexity, or not giving away on anything. One thing I'm going to show you in a minute in the demo is how I can essentially go and develop a real-time pipeline that comprises of very complex set of operations, data processing, model serving, ensembles, and all of that. I can do it with just a few lines of code. I can test it in the cloud, and I can deploy it onto the edge in a single command. Okay, so that is essentially what I can show now. And so essentially, I'm opening here a SageMaker. And one of the things that I need to do in order to connect to the cluster, I'm putting here environment variables is also credentials, but I won't show you my credentials. Connect my SageMaker into the remote cluster. That can also be passed as a parameter. And let's build a pipeline. So our pipeline may have a classification model, which is a class, may have some other type of operators and functions. And then I need to just take all of that, create a new serverless function. And for that serverless function, I'm just going to take a model that was pre-baked. It's in some sort of object store, but that can actually be taken from SageMaker. So SageMaker can run, do the training, generate the model, the pickle file, and then we could just take that pickle file and push it to the deployment in the edge. This is where we build a graph, and the graph consists of different steps like ensembles and model classification, etc. So we essentially build that graph that we discussed. We can just go and run some testing using dummy iris data against our system. We can test it locally using what we call a mock server. It's like emulates the real-time pipeline. We can see how it behaves. And when it's okay, we can just say deploy. And then it's essentially going to deploy that function. You see what it's doing. It's taking my code. It's building the containers. It's distributing it to the edge. It's verifying that it's working. And essentially, it even reports back what the HTTP endpoint for my real-time pipeline. And I could just go and invoke and give it some data, this iris dummy data, and get back a response. So I can build an entire pipeline with a notebook in SageMaker and deploy it to the edge location with a single deploy command. This is essentially the trick. So going back into by the way, if we want to see how it works, then essentially if I go into the quasi cluster, which is on the different location, we can actually see the code that was in my SageMaker notebook. You see this classification model and all of that running on Nucleo on the dashboard in real time in this remote location. Okay. So the next thing, after we deploy the model, just deploying a model, that's nice, but it's also important to be able to monitor and govern the model. So those functions that are being deployed, they're connected to the feature store, and this is really where they get the real-time features and validation policies to be able to know how to respond and into the requests. Those serving function, they automatically generate a stream of log with all the activities that happen, all the requests, all the responses, the performance indicators, and all that. And that stream is connected to another set of serverless microservices that monitor that activity. They monitor, they compare the results with the statistics that were generated in training. So they can tell you in real time if there is a deviation between the way the model needs to behave, the accuracy, the feature histograms, etc., and the way the model actually behaves in real time. That could even be shown in dashboards, whether it's in the cloud or on the Outpost deployment. And if it deviates too much, you can actually trigger an alert and derive it to another serverless function or send a notification somehow, and you can push that forward. So it's not just the ability to create models and deploy them with a real-time feature engineering pipeline. It's also about collecting the data and being able to notify if there is any problem or retrain because all the data goes back into the feature store. All those features that we gathered from the production data are going back into the feature store. So essentially, with this approach of using a cloud like solutions in the on-premises and automation, just like the one I've shown, that together with the Iguazio and Amazon, we can shrink time to market significantly and save resources. And that's the key message. Okay, so with that, going back to you, Sar, and we can open it up to questions. And
Thanks, Yaron. Excellent. And I see we already have a few questions in the chat. Okay, and the first question is for you, Rob. Oh, this is a nice one. A bit of trivia. How much does the heaviest Outpost rack weigh?
Great question. Our Outposts are not light, that is for sure. The heaviest rack that we've configured comes in at just shy of 1,700 pounds. And fun fact on that, we actually have taken one Outpost from the truck to the customer's facility using a crane because we were unable to rely on the elevator, which wasn't rated to hold that much weight.
That's amazing. We have a bunch of other questions. This one is for Yaron. Can the Iguazio dashboards be seen on AWS dashboard?
yes, I'm not sure which AWS dashboard you mean, like the UI console. It's not there, but all the Iguazio dashboards have open APIs, and they also support Grafana and Prometheus APIs. So if you use more sort of open or standard dashboard, you can just plug those data sets in those. There's also SDK and API. Again, it's based on an open source component called MLRun and Nucleo. So all those things have open interfaces and already integration with a bunch of tools. I can take the second question on sort of Iguazio as well.
Yeah, feel free. I'll
So
just
we
read
have,
it out for everyone. Does Iguazio make sense for only established companies or even smallest of startups as they're wrangling their data?
so we work with both. On one end, sort of like big banks and financial services. On the other end, small startups. There is actually a great use case and testimonial from a company called Quadient using us. And they're talking in this testimonial how they actually managed to build all this complexity using a couple of guys. And if they wouldn't use the Iguazio, they probably need to hire like a lot more people, and it would have taken them significantly more time. So you can start with Iguazio running on a single or a couple of VMs, and you can scale to much more than that. And it's sort of software licensing on top of your Amazon VM, so it's not too expensive, and it saves tons of. Actually, for small companies that don't have all the amount of personnel that large companies have, sometimes this level of automation and pre-integrated solution make a lot more sense.
Excellent. Thanks, Yaron. And another one for Rob. This is a fun one. What are you most looking forward to in 2021?
Gosh, great question. I'm just really looking forward to continuing to see more and more customers deploy Outposts and build their workloads. But I really do think the servers that we're building are a whole new chapter of this business that we're getting into, and just the conversations we've had so far. While they're still architectural designs and theoretical in nature, we've really just been blown away by some of the ideas and plans that customers have for those Outpost servers, and I'm really looking forward to seeing those begin to become reality later this year and carry us into 2022 and beyond.
Absolutely, and it looks like that's definitely the trend. That's definitely where it's going. Okay, looks like we've covered everything. So we are coming to the end of our session, and we really hope that you found it interesting. Before I take a look at the poll results together with you, I'd just like to invite you to learn more about bringing data science to production on the Iguazio website, where you can find the case studies that Yaron mentioned earlier. And also in our MLOPs section, you can find previous sessions of this webinar series. We've had 12 so far. blogs, videos, and other resources, all aimed at simplifying your path to production. You can hear from Siemens, S&P Global, Netflix, Twitter, and many other industry leaders speaking about their experience in operationalizing machine learning. And now we will show the poll results, starting with the first one, which was, what main challenges are you currently facing with your hybrid deployment strategy? And most of you are handling complexities involved in working with different APIs. 56% marked this as the most significant response. There are also challenges around performance, insufficient internal resources or manpower. And some of you, some lucky ones, aren't currently facing any challenges. 3% are not facing any challenges right now. And let's take a look at the results of the second poll. This one was about whether you currently have a good solution to run hybrid workloads. And 22% of you are happy with your current solution, and the rest are looking for a good solution. Well, 37% are actively looking, and 41% don't currently have the need, but are learning about this subject. And that concludes today's session. We invite you to continue chatting with us on our Slack channel. We'll share the link in the chat box again now for anyone who missed it before. And next time, we're going to be discussing feature stores in depth. So make sure to join us. And at this point, I'd just like to thank Rob and Yaron for the fantastic presentation and for fielding all these questions. And thanks everyone for joining us.